Hey guys, today's video is on triangle proportionality, including parallel and perpendicular parts. So we're going to start with a little bit of vocab. The triangle proportionality theorem says if a line is parallel to one side of a triangle and intersects two other sides, then it divides the sides into segments of proportional lengths. What that means, again, is we have parallel side in the middle with another parallel side on let's say the bottom of this triangle. Then these two sides that it splits up into will be proportional, meaning that we can make a ratio out of them. So if DE is parallel to AC, then BD over DA is going to equal the proportion or the ratio of BE over EC. Now the converse is also true, going the other way. BD over DA, that ratio, if it is equal to BE over EC, then we can say that DE is parallel to AC. Let's go ahead and start with one example. Number 1. So we're going to find the value of x here. Here we have two parallel lines, here and here. And if they're parallel, all you have to do is set up a proportion. And it's the easiest thing in the world. A couple different things you could do, but what I like to do is just literally draw fractions with an equal sign, just like that. And you can get the right answer. 14 over x equals 12 over 15. It's exactly that easy, just as the picture looks. That's all you have to do. Cross multiplying now. 14 times 15 is 210, equals 12x. So x is going to be 17.5. Same thing for number 2 or number 4. Let's skip to, number 4. Again, all you have to do is set up, since the lines are parallel, two fractions. Okay, so we have 7 over 6. But then that x is being divided by not 27. Be careful here. This side is 21 because the whole thing is 21. So x over 21. And it's just that easy. We have all the parts being proportional to each other. And then you would cross multiply and solve. And if you did that, your answer for here would be 24. Looking at a little bit tougher one. Looking at maybe number 6. Again, so easy. You make your fractions equal to each other. This would look like 6 over 21 is going to equal x minus 1 over 3x plus 1. Just be careful when we cross multiply here. You need to distribute. So it's going to look like 18x plus 6 is going to equal 21x minus 21. Going ahead and solving, we get 3x to equal 27, so x is 9. Moving on. Let's go to new theorem. Let's go to parallel lines and proportional parts. So this says if you have 3 or more parallel lines, such as, let me get my highlighter, such as this one, or this one, and they intersect through two transversals, let's say here and here, then they cut off the transversals proportionally. That means they're going to be proportional to each other. Here's what we can write. If we have line AB is parallel to line CD is parallel to line EF, then the sections will be proportional. So section AC over CE will be proportional to BD over DF. AC, CE will be proportional to BD over df. This is also really easy if you follow my little trick. You just look at the picture and it literally tells you how to write your fractions. 45 over 18 equals 52 over x. That's all you have to do, cross multiplying and solving. We get 20.8 to be x. Okay, looking at a little tougher one. Maybe we did number 13. Let's make our fractions. 28 over, and it's not 92. You have to do subtraction, so you get 64 here equals 31.5 over x. And I'll leave it up to you guys to cross multiply and solve that one. And that is pretty much it for today. We can even do another one down here, making your fractions, setting them equal. The only thing you have to worry about here again is distribution when you are cross multiplying. Write down any questions you have on parallel lines, proportional parts, and have a great night.